Which of the following could be prepared in good yield from an excess of benzene in a Friedel-Crafts alkylation reaction? So in a Friedel-Crafts alkylation reaction, your reagents are some sort of alkyl halide and a Lewis acid catalyst. And so what you're going to generate as your electrophile in this reaction is going to be R+, essentially. So you're going to get a carbocation as your electrophile in this reaction. And so what this question is really getting at is the stability of a carbocation. So for each of these, to determine if we could actually make it in good yield, we want to take and kind of sever that bond to the benzene ring and think about what carbocation would be required to make this molecule. So if we look here in A, in order to add that straight 4-carbon atom chain, we would have to start with a primary carbocation. And so the problem with that primary carbocation, if you could even get it to form, is that it's going to immediately rearrange and at least move to that secondary carbon next door. And this would happen really fast. So if you were trying to put this straight butyl chain on there, you would not have success with that. What you would end up doing is instead forming the new bond to the second carbon of that chain. So rather than making N-butyl benzene, you would make sec-butyl benzene. And so anytime you try to put a straight carbon atom chain, you're going to end up with that same sort of problem. So this would be the carbocation that you would be requiring, but that would right away rearrange in the same sort of way that we saw here in A to an isopropyl group. So you'd end up putting an isopropyl group on that benzene ring instead. Here in C, this would again require a primary carbocation, and this would also rearrange right away because we've got this tertiary center next door, so that would rearrange to give you this tert-butyl cation, which of course is stable, and that actually happens to be the carbocation that would be required here in this last one. So here you would actually have some success because the carbocation that is required to form this substituted benzene is already stable. So this would be something that we could prepare in good yield in a Friedel-Crafts alkylation reaction. And so let's take a look at what this reaction would look like and use this as an example to draw a mechanism for a Friedel-Crafts. So to make D, you could start with benzene. And so you'd want to treat it with the tert-butyl halide and an acid catalyst. And so that would give you the tert-butyl benzene. So let's take a look at the mechanism for this reaction. So the first step is going to be to generate that good electrophile, that carbocation that would be required. So you're going to have your halogen, so this tert-butyl chloride. So the halogen of that tert-butyl chloride is going to react with the Lewis acid catalyst, which is aluminum trichloride, in a Lewis acid base reaction. So we're just going to coordinate that chlorine to that aluminum. Okay, so we'd have a negative charge on the aluminum, a positive charge on the chlorine, and then this can break to give you the carbocation that is needed. And so once you have the carbocation, this is a really powerful electrophile, and now the benzene could react with this. Right, so your benzene is a nucleophile, so you could, since it's unsubstituted, you could draw this arrow from any one of those pi bonds, and it's going to form a new bond to that carbocation. So we have the new bond to the carbocation. We still have that hydrogen at that center that we're going to need to take off in the next step. And so whatever base you have in solution, in this case we've got some aluminum tetrachloride that could act as the base and remove this hydrogen. And in doing so, notice when we cleave this bond, we'll regenerate that aluminum trichloride, which is the catalyst in the reaction. So that would be the mechanism to form D. And this would work because this carbocation is stable. All of our other options had carbocations that we wouldn't reliably be able to form. They would rearrange, so we wouldn't form the connection we'd be wanting to form to make any one of those. So A, B, and C, we could not make those from Friedel-Crafts alkylation, but they could be prepared by a Friedel-Crafts acylation followed by a reduction.